guys, so today you and I are going to talk about Borderlands. So let's get into it. So, what we're going to cover in this video is basically a story, a very short story, I hope, from work, and how a fairly serious bug actually happened due to something that is the worst of the worst, which is shared code, and then how to avoid it. So let's dive right in. So my story from work starts with an innocent, tiny little system. Well, it's actually not that tiny, it's actually pretty big. But the scope of the problem is fairly small. So in this scope, we had this service that looked something like this. So we have a product service here, and as you can see here, it depends on a product recommendation service, a provider service, and then it has a few functions that are kind of just fake now for just to keep things simple, right? So we can get a product, we can create a product, and then we can delete a product. Now the interaction that we have is basically okay. So we have different products in the system, and we have different providers that are associated with the specific product. And then we have the product recommendation service, where whenever a new provider uploads their new products to the platform, well, then we might want to send a push notification or recommendation or something like that to the user. So the product recommendation service needs to be invoked whenever we make a change to a product, or we create a new one, so that we can see if we need to tell the user about the fact that this thing happened. And in the case of deleting a product, well, then we don't want to have that recommendation live anymore, right? We want to remove it so that the user doesn't get a recommendation for a product that does no longer exist, right? Now, this is where it all started. The reason why it started is because my team was responsible, or our part of the system was to deal with the product and the provider. Our deal in the system, our sphere of influence, is related to the actual uploading of products and the management of products. And then the other team that had the product recommendation service, well, they had a new feature request where this feature was added. So what they had to do, because they own the recommendation portion of the system, well, this is what they did. So what they did was that they went into our system, like this is my code here, basically. Well, my code is much nicer than this, but it's sort of my code. And they injected this call here, and they injected this call here. Now this was a while back. So what happens is the other day that we get a bug report, and someone explains that a customer calls in and says, "Hey, what a weird thing. I have a bunch of recommendations for goods and services or products. That's like really weird. Like it's super cheap. Like it's just a few crowns." And so we investigated, and it turns out that the test environments, or rather the logic that was used in order to create a product, well, the recommendation team never actually accounted for whether or not a product was supposed to be shown to a user, or if it was created for internal testing purposes. So we displayed information towards the user that was not supposed to actually go out and be recommended. Now, the reason why this happened is because what I call border code. Now, Borderland code means that you and another team, you own a certain percentage each. Let's, for the sake of argument, say 50-50. You each own 50-50% of a feature. That is a problem. It's a big problem, because unless the teams have a complete understanding of anything that changes on one side or the other of these interfaces, or they have a difference of understanding in how the other team's part of this feature is supposed to work, there's going to be a problem. There's going to be a big problem. That's exactly what happened. Because what happened was that the team that had the recommendation service, they had no idea that there was more than one way to create a product, because they had not actually taken the time to check out how our feature worked. They had simply added this and assumed that the only time you can create a product is if you are intending to show it towards the users, which was not the case. And anybody on our team more or less would have known that that was the case. But on the other hand, when we reviewed this code, because of course they didn't just add it in, nobody actually reflected on our side of the team that, well, maybe we don't actually want to show a recommendation towards the user under all circumstances. And so we started discussing back and forth. How can we do this? And then I pointed out and I said, one thing that I really don't like with this implementation is the fact that you have let your business logic mess up our interface. And so the other team and my teammates, they kind of go, what do you mean? Well, if you have a look at the dependencies here, you have injected a product recommendation service, but you also have a provider service. Now, if you look through the code, the only reason we have a dependency on the service is because of you. Because you need that information as part of your interface. So you have coupled your business logic, the way that you need things, like what you need in the recommendation team, to our needs. And we need to decouple this even further, I would say. We need to get to a point where you simply are notified of the fact that something happens, and then we will have to have an agreement. And the agreement is going to be very important because you are basically our stakeholder in this. In other words, we have to agree on that our team will have to create some type of system or event system that will notify you when something that you want to know has happened. And so we discussed it and we arrived at something like this. I'll show you an example of how it can work. So we created a new version, a better version, an improved version, which is called Product Service version 2. It's much better. And in Product Service version 2, we have created something called a event listener. And you probably have heard about this before. And so here we could actually now, in the real code of course, we could reduce down the dependencies and all of this stuff and the logic of the product service down to a one-liner basically, where we stated to the other team, okay, we will agree on an interface, and this was the interface. So we created an interface that is this interface over here, where we state, okay, we will expose in our code, or rather we will have a service that in our code is going to fire an event. And if we create a situation where product is supposed to be public, in other words, it's safe for you now to go and recommend this product to a user, we will fire this. We will send you a push notification, like we will in essence send a webhook request or a network call or publish an event or something like that. We will notify you that this is happening. You are responsible for the logic of what you do after that. So we don't want you to take any of our domain models or anything like that. The only thing we will send you is the ID of the product, because that is the minimum thing that you need to know in order to act on the information. And the same thing goes for when something is private. This way we decouple our logic so that when we then break out of this monolith, because in this case it was a monolith that we were working with. So when we start making an implementation that is more service-oriented or microservice-oriented, we will do the same thing. We will simply send you a message, and then it is up to you to go and fetch all the information and do whatever business logic that you need. And on your side, you will implement a similar interface, so this is a shared interface, that just knows that, all right, there's an endpoint that we're going to call, and that endpoint is going to receive either that it's public or that it's private, and that this product was the thing that changed the state. Now, the responsibility of our team is to, of course, also now remember all the situations when this can happen, because in the real code version, there were many things that could create a situation where a product could become private. And that's the tricky part, because in this scenario, we actually had a secondary bug where, somebody had forgotten that if a provider no longer wants to be part of the platform, well, then we have to remember to remove all of their products. And that had also been missed. So that becomes the ownership and responsibility of my team, who's supposed to take care of the products. And we now have to set up a contract with the external team that takes care of the recommendation, and they will have to trust that we have a good understanding of when do you want to know that something happened. And so we discussed it back and forth. And as I said, we finally arrived at something like this. And this is fairly, I would say, it's actually fairly elegant. It's and the same thing went here for, like, we updated the provider service in a similar way, where we realized that, well, if the state of a provider actually changes, as I was saying, there was a secondary bug to the whole thing, then we also need to fire these events. And since we don't want all the business logic of the other team to fall into our system and our part of the code, they shouldn't be touching this. This decoupling actually made a lot of sense. It made the whole thing a lot easier. And we could even, actually, you don't have to just think about this as something that you will do if you have two different services. It makes a lot of sense if you have two different services, and if you do any research on microservices and event queues and so forth, you should recognize a pattern similar to this. But even if you're all on the same code base in a monolithic application, this makes a lot of sense, because conceptually it's the same thing. We do not want this. We don't want another team to inject all of their different services and their business logic. This is just a token representation, but they had a lot of if and else's and stuff like that. So they had messed up the cleanliness of our logic in here to just accommodate this call. And by simply doing this, moving it to saying that, oh yeah, you give me a listener and a function, and I promise you I'm going to call this function or this hook. And then you are responsible for implementing this interface in your part of the code. And that's going to be our contract. By just doing that, we actually decoupled the code. And now the real issue, which is the thing that I want you to take away from this, the real issue now becomes, okay, what if the feature changes? How are we going to manage those expectations? Because basically, it's a similar problem to how, say, a company such as GitHub or similar sort of organizations, when you have a bunch of third-party apps that integrate to your APIs, and you're supposed to publish events or things like that, or use webhooks and so forth, you have to document fairly thoroughly under what circumstances you will send. So, for example, product is public or product is private. And it's really important now that since you're two independent teams in our scenario that own a part of the same feature, well, we need to synchronize back and forth. We can't get away from that because that is what the requirements of the feature is, but we can decouple ourselves so much that the surface area that we have to interact on is as low as possible, which is a very good thing, because now all my team has to remember is that, okay, does this thing that we're doing, is that going to require us to say that, or this thing, that the product is now public? Or does it mean that it's private? As an example, in this scenario, it's very straightforward, but we also have to remember that, well, changing the provider state or like deleting a provider, that also means that we need to either set the products to public or the products to private. So now that's all part of the contract. We need to know when this happens and have a dialogue with the other team. And the other team, if their circumstances changes, they have to communicate to us. And that's that inter-team communication that you've heard so much about. So what I want you to take away from this is that if you want to deal with other teams and multiple teams owning what I call shared code or Borderland code, where you own both two teams own pieces of the same feature. Ideally, you don't want that. If you can if it is at all possible, a team should ideally own an entire feature. But sometimes the system is simply too big that it's not possible. If it is not possible to do that, really consider using a system like this, where you have a event-based mindset, where if another team needs to know that something happened in your part of the code, then expose a listener interface of some sort, such as this, and simply tell them that, okay, I will call this function if this happens, and I will call this function if that happens, and then have a dialogue between the two of you. And this will work both in a monolith, and it will work at scale with microservices and all that stuff. The only difference is that in a monolithic application, they simply provide like a class or something where you can instantiate it and put it in your service. And in a microservices architecture, you have something like an event queue or similar system where you just publish a message and they should consume it in their part of the system. Hopefully you found this useful. Have a great day.